Hi guys, welcome back to Mathematics for Engineering 3 for students in international programs at Kasetsart University. In the last video, we looked at how to solve equations, higher order differential equations, which are homogeneous, right? And we had we have three different cases, right? The first case when we have distinct root, right, and the repeated roots and complex roots, right? And you know how to solve the homogeneous linear equations using the characteristic equations, right? And then we could obtain the solutions. In this video, we're gonna be looking at the non-homogeneous linear equations, okay, when we have higher orders. Let's start first. Let's look at the form. Okay, so here the equation star is the one that we are going to be solving today. Okay, in the last video, this one is basically 0, right? And then we came up with the characteristic functions, characteristic equations, and then we solve the characteristic equations. We obtain the roots, right? And if we have the distinct roots, is e to the mt, right? If you remember, and we have the complex roots and the repeated roots as well. So today, it's not 0. And we're gonna be studying two methods. Okay, in this video we're gonna be looking at the first method, which is undetermined coefficients. Okay, well, so 3.1 undetermined coefficients. So the solution of star, okay, the solution of that equation, the non-homogeneous linear equations, is y equals yc plus yp, when yc is the solution of the homogeneous case. Okay, so you can compute yp using what we have learned in the previous video. Okay, when here is 0. Okay, so the remaining problem is that we need to define yp. Okay, so the method is that we first say that the solution y is actually the combination of two y's. One is yc and the other is yp. Okay, yc is the solution when the equation is homogeneous. Okay, so basically when rx is 0. Okay, so in that case we can go back to the previous video, right, and we can solve for yc, and then we need to come up with yp. But how? Okay, that's what we're going to be studying today. Okay, so the method, first we write the solution as y equals yc plus yp. Okay, this is the method. Okay, and yc, find yc where rx is 0. Okay, which is the same as what we did last in the last video. Okay, and the third step is, one of the most important steps for solving the non-homogeneous linear equations, which is to guess the form of yp using this table. Okay, so we basically need to guess the form of yp from R. Okay, so don't forget guys, we have Rx here. Because it's non-homogeneous, it's not 0. Okay, so when we look at Rx, we need to basically guess the form of yp. Okay, so basically, if Rx is constant times e to the ax, okay, if it's constant times e to the ax, you guess yp as a constant as well, which is a. Okay, for yp we are not going to be using c, Why? Because C are reserved for YC. Okay, so for YP we're gonna use the big A. Okay, so we're gonna use A1 e to the AX. Okay, so the form are similar, you know, from RX and YP. And similarly, if we have this form as Rx, so if you remember, this one is actually when you have M equals 0, 0, 0, 0, 0, 0 n times, right? Because if you have 0, 0, 0, 0, 0, 0, 0, it means that you have C1 e to the 0, okay, plus C2x e to the 0, plus C3x squared e to the 0, plus blah blah blah. But e to the 0 is 1, if you remember from the previous section. Okay, so you basically have C1 plus C2x plus C3x squared plus blah blah blah. So it's basically polynomials, right? You have Cn x to the n, Cn minus 1 x to the n minus 1. So you can guess if you see Rx in this form, you can guess that the solution is actually, many zeros. Okay, the roots of the characteristic equation is zeros, many of them. Okay, so in that case, the form for RP is going to be pretty much the same, which is A1 an x to the n plus an minus 1 x to the n minus 1 plus blah 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 plus a1x plus a0, and that will be the form of YP. Okay, that we need to guess. And here, if we have C1 cos AX plus C2 sin AX, it means that the solution of the characteristic equation is complex number. Okay, it's a complex number. Okay, so, and it's a complex number when the real part is 0. Okay, so basically if you see this part in Rx, your guess would be pretty much the same. A1 cos AX plus B, okay, I'll just use A2 sin AX. Okay, and the next one is when you have M equals A repeatedly for this one, right? Because you have e to the AX, C0 e to the AX, and then you plus C1 x e to the AX, right? That means you have A twice, and then you have C2 x squared e to the AX. It means that you have the third the third A, right? It means that you have like many A's, right? Repeated roots, okay, when the roots are A's. Okay, so your guess would be okay, well, it would be similar, which is an x to the n plus an minus 1 x to the n minus 1 plus blah 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 plus a1x plus a0, and then that times e to the ax. Okay, that times e to the ax. Okay, pretty much the same. Next, when you have this form for Rx, this form, if you go back to the previous section, is actually the form when you sorry, here is sine, it's not cos, it's sine. It's actually when you have complex root, repeated complex roots. Okay, so you have repeated complex roots when the real part is 0. Okay, and the imaginary part is A. Okay, so your guess would be pretty much the same. It would be a n xn plus an minus 1 xn minus 1 plus blah 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 plus a1 x plus a0 and then times cos ax, okay, plus a, okay, let's use some b, bn xn plus bn minus 1, sorry, bn minus 1 xn minus 1 plus blah 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 plus b1x plus b0 and psi ax. Okay, guys, it may be possible that you have less terms here than here, but when you want to guess the yp term, you need to take the biggest n. For example, if Rn is x squared plus 2x plus 1 cos 3x plus 2x minus 1 sine 3x, okay, so your yp should be a 2 x squared plus a1x plus a0 cos ax and b2x squared plus b1x plus b0 sine ax. Okay, even if you have only two terms here, but you know that when you have complex roots, they come in pair, right? You have both. Okay, so you need to take the highest order and use it. Okay, and similarly, guys, for the last one, it means that you have m equals a plus minus bi repeatedly. Okay, you have many a plus and minus bi. Okay, you have repeated roots. Okay, and but the roots are complex. So basically, you get the same structure, which is a n x to the n plus a n minus 1 x to the n minus 1 plus blah 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 plus a1 x plus a0 e to the ax cos bx plus bn xn plus b n minus 1 xn minus 1 plus blah 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 plus b1x plus b0 e to the ax psi bx. Okay, and that would be the guesses for yp. Okay, it's not very hard to memorize the yp forms, right? Because they look pretty much the same as rx. Okay, but you just need to be careful. Sometimes, as I told you, you don't have the complete form. Okay, you might have just some of the forms, but you need to be able to identify that it's actually this form. You know, things will be clearer when you see the examples. Okay, so first, okay, let's look at, oh no, sorry, it's not done yet. Okay, it's not done yet. Okay, first you write the equation, you write the solution as yc plus yp. Yc, you can compute that using the previous section materials, right? So basically you let rx be 0 and then you compute yc, and then you need to guess the form of yp. Okay, and number 4, you need to consider yp that you have guessed. Okay, and whether or not it has the same term as yp, sorry, as yc. Okay, for example, if you guess p to be e to the 3x a1, but when you solve for yc, yc is also e to the 3x. Okay, they are the same, they are from the same roots. In that case, if yes, you need to multiply the terms which are the same for yc and yp by x to the n. Okay, when n is the smallest number, that make yp not the same as yc. Okay, but if no, you do nothing. Okay, just know this first. Okay, just know this first. You guess yp, and if the solution of yp is pretty much the same as yc, you need to multiply x to yp so that they aren't linearly dependent. Okay, things will be clearer when we see the example, but I need to to sum all things up for you to to see here. Okay, and then you put yp in the star and find the coefficients ai. Basically, you put yp in here, and then you find the parameter a's here, the coefficients. Okay, you see. Okay, first let's look at this example. So first step, I'll just write y equals yc plus yp. Okay, and to find yc is from this equation, right? It's from this equation. Okay, this is to find yc, and to find yc you have the characteristic equation, which is this guy. Okay, and then you factorize it. It m 2 1 plus and minus, and m is 1 and minus 2, which means that your yc is actually c1 e to the x plus c2 e to the minus 2x. Okay, and that is your yc. And then if you look here, third, you need to guess the form of yp. Okay, and if you look here, there are two of them. There are two forms. Okay, you can probably write yp1 equals, for the first form you have 2x. It means that it's actually from this one, a x a1 x plus a0. Okay, it's actually from this form. As I told you, for Rx, it might be a fraction of forms. So you need to be able to identify. You might not see 2x plus 1, or x squared plus 2x minus 1. Like, you might not see the whole form. You might see just x squared minus 1. You need to be able to identify that it's actually from a2x squared plus a1x plus a0, when a1 is actually 0, so it disappeared. See, you need to be able to tell. So here, when you have 2x, it means that your yp is actually a1. Yp is actually a1 plus a2x. Okay, when a1 is 0. Okay, when c1 is 0 from the Rx. But it might not be the case for yp. So you need to be able to guess the full form. Okay, and similarly, for the pink color, you have only cos 4x. See, you have only cos 4x, but you know that the solution, when the root is complex number, they always come in pair, right? So this one is actually this form, isn't it? Is c1 cos something x plus c2 psi something x, right? It's actually from that one. But you can only observe this. Maybe C2 is 0, maybe, I don't know, just disappeared. Okay? But you need to be able to identify the full form. Okay? So in that case, you have this as a B1 cos 4x plus B2 psi 4x. See, you can guess yp from, rx. So, but this case you have, two separate forms. So yp, they need to have two separate forms as well. But the yp is actually the sum of those. See, this is actually the full form of that. I just break it down to yp1 and yp2 to make it easier to explain, okay? But actually it's just one yp, okay? And that's the third step, okay? And for the fourth step, we need to see whether or not the form from yp is actually the same as yc. But you know that yc is when we have, these two roots, right? But this one is from the complex root, right? This one is from the complex roots, which is not the same as that. Okay? Okay, as I told you, the fourth step, if you don't remember, the fourth step is that you need to see whether or not yp has has the same terms as yc. But as you can see, yc is all exponential, right? Which means that m is 1 and minus 2. But yp here, this guy is when you have m equals 0 and 0, right? If you have m equals 0 and 0, you will get constant e to the 0 plus constant x e to the 0, which is constant plus constant x, right? Which is this guy. See? And this one is when we have complex. So the roots from yc and yp aren't the same. Okay? So we do nothing. Okay, we don't need to multiply x, blah blah blah. You will see in the next example when we need to multiply some x to yp. Okay? But not for this one. So the fifth one, we need to put yp in this equation in order to find a1, a2, b1, and b2. Okay? Okay? So if we want to find if we want to substitute that, it might be easier for us to write yp prime first. Okay, if I want to write yp prime, I would get a2, right? Because the relative of a1 is 0. It's constant, right? The relative of this is this disappear, so we have a2. And then we have the relative of cos is minus psi, so we have minus psi 4x. Okay, and by chain rule, okay, let me write it this way. We have b1 here. The relative of cos is psi, but by chain rule you have 4 here as well. Okay, and again b2, the relative of psi is cos, so you have cos 4x, and by chain rule you have 4 here as well. So basically it's a2 minus 4b1 psi 4x plus 4b2 cos 4x. Okay, and then we find a yp double prime, which is, okay, the derivative of this is 0, so we have minus 4b. The relative of psi is cos 4x, and we have another 4 here, plus 4b2, derivative of cos is actually minus sign, 4x, and we have another 4 here, so it's minus 16b1 cos 4x minus 16b2 sine 4x. Okay, so now we have yp, y prime p, y double prime p. So we then can substitute yp, y prime p, and y double prime p into this equation. Okay, and that is not going to be fun. Okay, that's not going to be fun. Let I go to the next page. Okay, and let me do some copy and paste. Okay, I'll delete them later, but I'll do some copy and paste first. Then I'll just copy this as well, just for you guys to see, but after that I'll just delete them, put them here, just for you guys to be able to see the terms. Just put them here. So in that case, if I want to substitute this into the equation, what I would have is, what is it, minus 16 b1 cos 4x minus 16 b2 sine 4x, that is y double prime. Okay, this one is actually this guy. Okay, and then we need to plus y prime, which is a2 minus 4b1 sine 4x plus 4b2 cos 4x, and that is plus y prime. And then that's not done yet. We have minus 2y, but y is, what is it, a1 plus a2x plus b1 cos 4x plus b2 sine 4x, and that equals 2x plus 34 cos 4x. Okay, we basically substitute all the things in there. Okay, and then we hope that we can find a1, b1, b1, a1, a2, b1, b2. Okay, sorry, you can't see the y's. Okay, is that good? Cool. Then I'm gonna rearrange the terms. Okay, I'm gonna rearrange the terms. First, I'll just look at the constant term first. Okay, I'll look at the constant term first. The constant term would be this guy and this guy, right? The term without x at all. So we have a2 minus 2a1, right? That is the constant term. Okay, and then if we look at the term with x, with only one x, okay, with only x, it's actually only this term, isn't it? Right? So we have minus 2 a2x. Okay, so we have minus 2 a2x, and after that we look at the cos 4x term. Okay, the cos 4x term. So if we look at the cos 4x term, what we have is this one, which is minus 16b1, and then we have this one as well, which is plus 4b2, and then we have another term, which is this one times this. So we have minus 2b1 cos 4x. Okay. Is that good? Okay, guys, I'll just delete, these because we don't need them anymore. And then we look at the side term. What is the side term? The side term would be minus 16b2 from here, right? The coefficient of sine 4x. Okay. And then we have minus 4b1. This guy. And after that, we have b2 here, minus 2, multiply. So we have minus 2b2 sine 4x. And this guy equals 2x plus 34 cos 4x. Okay, let me rearrange it a little bit to make it look a little nicer, okay? So I have a2 minus 2a1 minus 2a2x plus there would be 4b2 minus 18b1 cos 4x, right? Right? Okay, I just move this to the front, and here is 18 minus 18. Okay. And the last part is, what is it? It would be minus 18b2. Okay, how about I say plus minus 18b2 minus 4b1 sine 4x equals 2x plus 34 cos 4x. And then we compare the coefficients of both sides okay? As you see here, there are no constant, right? You have some x, you have some trigonometric functions, so then there's no constant, which means that a2 minus 2a1 is actually 0. Okay, and minus 2a2 is actually 2. Okay, because you compare this coefficient with that. See, the coefficient of x. Okay, and we have that 4b2 minus 18b1 is actually 34, right? We look at the coefficients here. Okay, and the last one, minus 18b2 minus 4b1 is 0 because you don't have the side term here, which means that you may probably have 0 sine 4x. Okay, which means that this guy should be 0. Okay, and then we have 4 equations, 4 variables. You should be able to find all the coefficients, right? For example, for this one, you know that a2 is actually minus 1. Okay, and if you know that a2 is minus 1, you know that 2a1 is actually a2, which means that a1 is minus 1/2. Okay. And here I'll just divide the whole thing by 2. So I get 4 here, I get 9 here, and I get 17 here. Okay, and then I multiply sorry, I get 2 here, not 4. Oops, sorry, I get 2 here, not 4. Okay, and then I multiply the whole equation by 9, so I get, what is it, Is there any other ways to make it easier? I think it looks a little bit harder this way. Maybe it can be a bit easier. Okay, anyway, I'll multiply the whole equation by 9. So I get, what is it? 18b2 minus 81b1 equals 153. Okay, and then I take the sum of this equation and this equation. Okay, so these disappeared. Okay, so we have minus 85 b1 equals 153. Okay, and here we have that b1 is actually minus 9 over 5. Okay, so when we have that b1 is minus 9 over 5, we just substitute b1 back into this equation, so you can get b2. Okay, I'm not gonna be computing, okay, I'm just gonna give you the value, which is 2 over 5. Okay, so in that case it means that your yp is actually what is it, a1 which is minus 1/2, okay, plus a2 which is minus x. Okay, and okay, let me copy this so that we can see it. We don't need to, you know, jump from between two pages. Make it a little smaller here. So, and then we have b1 which is minus 9 over 5 cos 4x, and then we have b2 which is plus 2 over 5 sine 4x. So the solution is yc plus yp, which is, what is yp again, guys? Yc is c1e to the x plus c2e to the minus 2x, and then you just copy and paste this guy to plus here. Okay, plus yp. Sorry. Okay, and that's it. That is the solution. Okay, let me write it down. Minus 1/2 minus x minus 9 over 5 cos 4x plus 2 over 5 sine 4x, and that is the solution. Okay, see, so first you write y as yc plus yp, and you find yc from, you know, when r is 0, and you get yc, and then you just guess the structure of yp, the form of yp, and then as you can see here and here, they are not the same as that, because here there's exponential, right? Because m is 1 and minus 2, but here, as you can see, m would be 0 and 0, and here it would be complex, so they can't be the same. So step 4 we do nothing, and step 5 we compute, you know, all the derivative and plug into that equation, so that we can find all the parameters, okay, all the coefficients, sorry. Okay, so once we get all the coefficients, we can write down the yp, and if we can write down the yp, we know the solution is yc plus yp, which is this guy. Okay, and it's as simple as that. Is it good? Okay. Okay, let's look at another example. This one. So first we would write the solution y as yc plus yp, right? Similar to what we did. And then we know that yc can be obtained by solving this equation. Okay, which means that we have characteristic equation, this one. Okay, and to solve this we need to we basically need to get the root, which is m and m, 2 and 1, which is plus and minus equals 0. So yc is c1 e to the minus x plus c2 e to the 2x. Okay, and third we need to look at the form of yp, right? I'm looking, it's pretty much the same as in the previous example. So guys, can I skip this one? Okay, I'll let you guys do it yourself. Okay, I'll do the next one. Okay, because this one is very similar to the previous example. Okay, I'll just do this one. Okay, so this one first, y is actually yc plus yp, and this is the solution. And yc can be obtained by solving this equation, and the characteristic equation would be m squared plus 1 equals 0, which means that m squared is minus 1, which means that m is plus or minus square root minus 1, which is plus or minus I. Okay, so we have that our yc is c1. Okay, if you remember, c1 is actually e to the, guys, when I write plus or minus I, it's actually the same as to write 0 plus or minus I, right? Okay, so for this form, if you remember from the previous video, is e to the, what is it, e to the 0 x a, sorry, c1 cos x plus c2 psi x. Okay, and that is actually c1 cos x plus c2 psi x. Okay, so next we need to basically, third, we need to determine yp, right? We need to guess yp. And what would be the good guess for yp? Yp is psi x, right? So the guess for yp is probably a1 cos x plus b1 psi x. Okay, but guys, the fourth step is to see whether or not yc and yp are the same, right? For some terms. And as you can see, here you have psi x and here you have psi x as well. It means that they are from the same root, right? So to make them linearly independent, so we need to rewrite our yp as, then I multiply yp by x. See, right now they are not the same. So this is what I meant when I was saying that if you have yp and some roots of yp is the same as yc, you need to multiply yp by x to the n. Okay, when n is the smallest number, that make them not the same. And here I just need to multiply yp by x, so I get x psi x. Okay, so here it's not our yp anymore. Okay, this is not our yp anymore. We don't need them anymore. We're gonna use this one. Okay, and after that 5, we need to find yp prime, which is a1, and then we have the udv plus vdu, right? So we have x, derivative of cos is minus psi x plus cos x, and then plus b1, what is it? Actually guys, can I use a1 a2 or just a and b? Would that be fine? Because we have only one term. I don't know why I put a1 and b1 there. I just need a and b, right? Okay, so here it would be x, derivative of psi is cos plus psi x. Okay, and that is y prime. Okay, that is y prime. Should I rearrange it somehow? Maybe I should, right? Okay, so that is, what is it? B minus a x psi, no, is minus ax plus b psi x plus bx plus a cos x. Okay, and then we need to find y double prime p, which is, okay, here we need to use u dv plus vdu again. So we have u dv, which is cos x, plus v, which is psi x, du is minus a. Okay, and the other one is the same. So we have u dv, which is minus psi, plus v du would be b. Okay, so here is, wow, it's going to be minus ax plus 2b, right? Because you have another b from here, b cos x here. So you have minus ax plus 1b here and 1b here. So you have 2b cos x. Okay, and we have for the psi x, we have bx, no, we have minus bx minus 2a psi x, and and that is what we have for y double prime. Okay, is it cool? Okay, and then we put them in this equation star. So what we have is, what is it? What we have is minus ax plus 2b cos x plus minus bx minus 2a psi x, and that is y double prime, plus, okay, I'll move this a little to the left hand side, plus y, which is ax cos x plus bx psi x equals psi x. Okay, and I'm gonna move this whole line to the next page. Okay, oops. So what we have here is these cancel out, right? So we have 2b cos x, and similarly here cancel out, so we have minus 2a psi x equals psi x, which means that 2b is 0, okay, because we have actually 0 cos x here, and minus 2a is 1 because we have 1 psi x here. Okay, we just compare this with that and this with that. Okay, we compare the coefficients, so we know that b is 0 and a is minus 1/2. Okay, which means that our yp is, what is it, a, which is 0, a which is minus 1/2, x cos x, okay, minus 1/2 x cos x, plus b is 0, so you don't need to plus any b. Okay, so your solution y is yc plus yp, which is yc is c1 cos x plus c2 sin x minus 1/2 x cos x, and that is the solution. Okay, okay, is that good? Okay, the next example, this one, I'm gonna let you do as, exercise as well. You can try it yourself. It's not that hard. Okay, so it's quite easy. The next one, this one, let's let's try doing it ourselves. Okay, so this one, first we would write y as yc plus yp. Okay, and second, yc can be obtained using this equation, which means that our characteristic function is m cubed plus m squared minus 5m plus 3 equals 0. Okay, and you can do the synthetic division that I taught you how to do before, right? It's 1 minus 5 and 3, and I'll try 1 and then 1 here, 1 2 2 minus 3 0. Okay, bingo. Okay, so to be honest, I don't know it's 1. Okay, so here we have m minus 1 and m squared plus 2m minus 3 equals 0. And then I factorize this guy, which is m and m, 3 and 1 plus and minus equals 0. So we have m minus 1 squared m plus 3 equals 0, which means that m is actually 1 and minus 3. So we have that our yc is actually c1 e to the x plus c1x e to the x c2x e to the x plus c3 e to the minus 3x, or you can write it this way. Okay, and that is cyc. Okay, and if you want to find yp, you need to guess the form. Okay, and if you look here, you probably see one form here. Okay, when m is 1, right? That is when the root is 1, because it's e to the 1x. Okay, and you have, you know, some other form here, and you have another form here which is a constant, which means that m is 0. Okay, which means that m is 0. Okay, I can just write for you here if you want. M here is 1, m here is 0, because it's e to the 0, so you have only constant, right? And here is when m is plus or minus I and plus or minus I, two of them. Why? Because you have just cos here and you have x and the sine. Okay, which means that you have two of them, otherwise you won't have x and sine. Okay, so third, I'm gonna guess yp. Okay, so I'm gonna break it down to yp1, which is, what is it? When m is 1, right? When m is 1. So yp1 is a1 e to the x. Okay, yp1 is a1 e to the x. And then we need yp2 is, what is it? What is yp2? Yp2 would be a1 plus a, oh no, I already used a1, right? So how about I use a2 plus a3 x cos x plus a4 plus a5 x sin x. Okay, yp2 is actually from this. Okay, when you have one of these, you have sin x as well. When you have one of these, you have x cos x as well. That's why we have it like that. Okay, and the last one, yp3 is actually just a constant, which is a6. Okay, and y is just the sum of those, yp1 plus yp2 plus yp3. Okay, guys, number four, as you can see that here the root here is 1 and minus 3. Okay, but as you can see here, the root here is actually 1 as well, right? That's why you have constant c x e to the x. So you have the same e to the x here, right? But you already have constant e to the x, so you can't have it like that, right? You need to multiply this yp by x to the n, okay, to make it not linearly dependent. Okay, but x that you need to multiply is actually yp1 would become a1x squared e to the x. Why? Because if you multiply yp1 by just x, you still get this one, which is still the same. See? So the smallest x that you need to multiply is x squared, so that this term won't be the same as yc. Okay? 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 So right now, we have that our yp is actually yp1, which is a1 x squared e to the x, plus yp2, which is a2 plus a3x cos x, okay, plus a4 plus a5x psi x, and plus a6. Okay, and in that case you need to find y prime, y double prime, and in this case you need to find y triple prime p as well. Okay, guys, I'm not going to do that. Okay, I'm just gonna write it down from the book. Okay, you can just check it yourself. Okay, whether or not it's correct. Okay, I just write it down. It's a1 x squared plus 2x e to the x, minus a2 minus a5 plus a3x psi x, plus a3 plus a4 plus a5x cos x. Okay, guys, it's not fun to differentiate this function, right? It's not fun, but you can try. You're gonna get that yp prime. Okay, and y double prime would be a1 x squared plus 4x plus 2 e to the x, minus a2 minus 2a5 plus a3x cos x, minus 2a3 plus a4 plus a5x psi x, and that is y double prime. And the last one, y triple prime, is a1 x squared plus 6x plus 6 e to the x, plus a2 minus 3a5 plus a3x psi x, minus 3a3 plus a4 plus 5 plus a5 x cos x. Okay, guys, if you want, you can try differentiate this yourself and you'll see this is what you have. Okay, and then you need to substitute yp prime, yp double prime, and yp triple prime in this equation. Okay, in this equation, and then you obtain the solution. Okay, guys, I'm not going to do it. Okay, you can try it yourself. It's too long. Okay, so you have yp is 2x squared e to the x plus 3x plus 3 cos x plus x minus 2 psi x minus 2, and that is yp. So the y is actually just yc plus yp. Okay, guys, I'll just leave it like that. Okay, the next question, you are asked to determine yp of this equation without specifying its coefficients. So you don't need to to compute A1, A2, A3. That's good. This is good, okay? So we need to just specify the form of YP. Okay, we are asked to just specify the form of YP. Okay, so let's try it, okay? First, we just gonna look at YC first. We need to compute YC. Why? Because, some roots of YC might be the same as YP. And in that case, we need to multiply YP by X to the n, right? You remember, right? Step 4. Okay, so step 1. Y is actually YC plus YP. And step 2, we solve YC by this equation. Okay, and that gives us this characteristic function. And then I pull M out. Okay, and in this case, you don't need to do synthetic division. You can do this if you want. It's just M, and then here you have M squared plus 1. Sorry, M squared, and you have M plus 1. Here you pull 4 out, you have M plus 1. And then you pull M plus 1 out, so you have M plus 1, and you have M squared plus 4. So your M would be 0, minus 1, and plus or minus 2i. Okay, it's actually plus or minus square root minus 4, but this one is actually plus or minus 2i. Okay, so our YC would be C1 plus C2 e to the minus x plus C3 cos 2x plus C4 sine 2x. That would be our YC. Okay, and then if you want to determine YP, we need to look at Rx. Okay, and as you can see, it seems like we have 3 YP, which is this one, this one, and this one. You may say that M, they are the same. No, they aren't. This one is when you have M equals 2i, right? Sorry, it stops. 1 second. Okay, yes, back. This one is when you have 2i, when the real part is 0, right? Because you don't have e to the ax here, which means that a is 0. Okay, but this one, M is actually 1 plus minus 2i. Here's plus minus. Okay, and this guy is when M is 5. See? So you have 3y. Let's say YP1 is A1 e to the 5x. Okay, and YP2 is A2 e to the x cos 2x plus A3 e to the x sine 2x. See, even if we have just one of them, but we need to write both of them. Okay, we need to write the full form. Okay, And the last one is yp3 is a4 cos 2x plus a5 sine 2x. But guys, okay, sorry, this is step 3. And guys, step 4, we need to change yp3, right? yp3. Why? Because if you look here, you have the same structure. See, you need to multiply yp3 by x. So your new yp3 would be a4x cos 2x plus a5x sine 2x. So that is not the same as the yc. Okay, makes sense? So this one can't be used anymore. Okay, so our yp is a1 e to the 5x plus a2 e to the x cos 2x plus a3 e to the x sine 2x plus a4x cos 2x plus a5x sine 2x, and that's it. We don't need to, to evaluate the value of a1 and a2, a3, a4, and a5. Okay, we just need to write down the form of yp, and that's it. Okay. This one I'll let you do as the exercise. Okay, we will do it in the live class. So guys, how was it? I know it's tough and it's messy, right? It's so many A's, right? A1, A2, A3, A4, A5, A6, A7. There's so many of them. But guys, in the exam, we won't be so mean, to ask you to have like 6 A's and then to ask you to get all the value of A's. That would be too hard for you guys. Okay, but you guys need to know the steps. Okay, we might ask you guys to write down yp without computing A's. Okay, but if we want you guys to determine A's, determine the coefficients, the equation won't be so tough. Okay, it will be a short equation. Okay, but at least you need to be able to do them. Okay, you need to understand the material. Okay, so let's just to sum it up. Today in this video, we looked at the non-homogeneous equation, right? When Rx is not 0. Okay, and we know that the solution, first step, the solution is yc plus yp. When yc is the solution of the homogeneous case, when Rx is 0. Okay, so the second step, we let Rx be 0, right? And then we solve for yc. After that, the third step, we guess yp from Rx. Okay, the fourth step, we see whether or not the terms in yp are the same as those in yc. If they are, we need to multiply the yp, okay, the one that is the same, by x to the n. But you need to pick x squared, x cubed, x to the 4, x to the 5. It depends on, what is the smallest x that you need, what is the smallest order that you need, so that yp won't be the same as yc. Okay, and that's what you need to do. Okay, and the fifth step, you need to, compute y prime, yp prime, yp double prime, yp triple prime, depending on the equation, right? And then you plug in all the y's into the equation to find A1, A2, A3, A4, blah blah blah. Okay, and once you have all the coefficients values, you just need to write down y as yc plus yp, and that's the end of the story. Okay, I know guys, it's tough, it's a lot to process, but you know, exercise help. So if you have any questions, don't hesitate to contact me. Okay, we can talk about that. The exam is coming. Okay, the exam is in the end of September. Okay, so it's in the next 2 weeks. Okay, if you watch it today. Okay, I'm not sure when you're gonna be watching this video, but anyway, see you in the next video. Okay, bye bye, take care.